Okay, class, picking up where we left off at. We need to add 8 on both sides. We had x squared plus 6x plus 8 is equal to 0. And when we factor this, we will have x plus 4, x plus 2, that equals 0. We will set both of these parentheses equal to 0. And we will have x is negative 4, and x is also negative 2. So our final answer is x is negative 4, negative 2. Okay, now for problem 51. Now 51 is going to take up a little space, so I need to create some space. Problem 51. It says an astronaut on the moon throws a baseball upward. The altitude, height, h of the ball in feet, x seconds after he throws it is given by the equation h equals negative 2.7x squared plus 30x plus 6.5. At what time is the ball 12 feet above the moon's surface? So we will substitute in 12 for h. So we had 12 is equal to negative 2.7x squared plus 30x plus 6.5. Now we will subtract 12 on both sides. We will have 0 is equal to negative 2.7x plus 30x minus 5.5. Now, we cannot have our lead coefficient negative, so we would change the sign of everything here and still have it set equal to 0, which give us 2.7x squared minus 30x plus 5.5. Now we'll use the quadratic equation. We know our a here is 2.7. Our b is a negative 30. And our c is 5.5. So now we will have x is equal to the opposite of negative 30 plus or minus the square root of negative 30 squared minus 4 times a is 2.7 and c is 5.5. And this is all over 2 times 2.7. So x is equal to 30 plus or minus the square root of negative 30 squared is 900. Negative 4 times 2.7 times 5.5 will give us a minus 59.4 all over 5.4. So we have x is equal to 30 plus or minus the square root of 840.6 all over 5.4. Now, we need to put this in our calculator. So we will have x is equal to 30 plus the square root of 840.6 all over 5.4. And also x is equal to 30 minus the square root of 840.6 all over 5.4. Okay, now what we need to do is we need to put this in our calculator. So we would take, now I'm using a smaller calculator than what you would use. So what you would need to do is take the square root of 840.6, which will give you this large number, plus 30, which is this number here, divided by 5.4. And we can round this off to 1 decimal place, so it's approximately 10.9. Now we will go to the next value. We will have 30 minus, I'm going to have to use a parenthesis here, 30 minus, it'll be 840.6. That's the square root. And this will give us 1 point, this decimal here, divided by 5.4, which will give us approximately, if we round to one decimal place, it will be approximately 0.2. So our final answer is x is approximately 10.9, 0.2. Now let's go back to our original question. It says here, an astronaut on the moon throws a baseball upward. The altitude, height, h of the ball in feet, x seconds after he throws it is given by the equation here. At what time is the ball 12 feet above the moon's surface? So we would take these values here, and we would just add the word seconds behind them. So our final answer would be 10.9 seconds, comma 0.2 seconds. These are the approximate times here. And that is our answer for 51. Now we move on to problem number 52. Okay, class, we need to put these values into our calculator. So what we would have here is 30 plus, then we would need a parenthesis, and then we would have to type in 840.6. It's the square root. And our numerator would be 58.99 and something divided by 5.4. Now your calculator operates differently than this calculator here. So this would be approximately 10.9. Now we go here. We would add 30 minus parenthesis. We'll do 840.6 square root, close that parenthesis, and divide that by 5.4, which will give us approximately, rounded to one decimal place, 0.2. Now if we scroll down here, I wrote that out, x is approximately 10.9 and x is approximately 0.2. And we have x is approximately 10.9, 0.2, and we're talking time because we wanted to know about how long, as far as the time is concerned, about how long would it take for the ball to reach 12 feet above the moon's surface. It'll be at 10.9 seconds and 0.2 seconds. Now, we move on to problem 52. Now, there are a couple stray marks here that we need to get rid of. Just a couple, so don't worry about them. They're not going to affect the problem. But look at here, problem 52. It says a boy throws a penny upward from the top of a 48-foot tower with an initial velocity of 32 feet per second. After t seconds, the penny has height, and we have this formula here. After how many seconds is the height 64 feet? After how many seconds does the penny hit the ground? So let's start off with A. Okay, first of all, we will put in 64 for h is equal to negative 16t squared plus 32t plus 48. Now, what we would need to do is move this 64 over here with the rest of the equation. So we'll subtract 64 on both sides, and 0 is equal to negative 16t squared plus 32t minus 16. Now we know we cannot leave our lead coefficient negative, so we'll rewrite and change all of the signs of everything on this side of the equation. So now we can factor. We can factor out 16. We add t squared minus 2t plus 1. And when we factor this equation, we'll be left with t minus 1 times t minus 1. Now, we know we would not we could divide each side by 16. 0 divided by 16 is 0. We add t minus 1 and t minus 1. We know we only need to set one of these equal to 0. So we add t minus 1 equals 0. And our final answer would be t is equal to 1. So it'll be 1 second. So that answer is A. Now we want to go to B. Now B asks us, after how many seconds does the penny hit the ground? So we'll go to 0 because we know the ground is at 0 level. So we have 0 is equal to this equation here. Now we have to change the sign of everything because remember our lead coefficient cannot be negative. So we change the sign of everything. And now we factor out 16. We add t squared minus 2t minus 3. Now this factors out to t minus 3 and t plus 2. We divide each side by 16. And 0 is equal to t minus 3, t plus 2. Now we will set both of these values equal to 0. So we add t minus 3 equals 0, t plus 2 equals 0. So t is 3 and t is negative 1. Now we know we cannot have negative time. So our answer would be t equals 3 seconds. So this is our answer for B. Now we scroll down to our next problem. Now with problem 53, we have the annual percent increase P in spending on hospital services in the years 1994 to 2001 can be modeled by the equation P is equal to 0.37 t squared minus 4.1 t plus 12, where t is the years since 1990. Now it says predict the annual percent increase in 1997. So we know since 1997, since 1990, that's really just 7. So t, we will substitute in 7 for t. Now, we will put this in our calculator. Okay, I took the liberty of filling out the rest. As I told you all before, when we were here to use your calculator to complete this problem here, and it gave you 1.43. So that is your percent of increase, which is 1.43%, and that will be your final answer for A. Now we come to B. It says predict when the annual percent increase in hospital services will be 11.7%. Now, you will write just 11.7 without the percent sign because B is assumed to be percent. So you'll put 11.7 equal to this equation here. Then you'll subtract 11.7 on both sides. Now to give you 0 is equal to 0.37 t squared minus 4.1 t plus 0.3. And then we will use our quadratic formula. Our A is 0.37, our B is negative 4.1, and our C is 0.3. So we had our opposite of negative 4.1 plus or minus the square root of a negative 4.1 squared minus 4 times 0.37 times 0.3 all over 2 times 0.37. And that would give us 4.1 plus or minus the square root of negative 4.1 squared is 18.04 minus 4 times 0.37 and 0.3 will give us 0.44, and 2 times 0.37 is 0.74. Now when we subtract these values, we're left with 7.596, and then we would take 4.1 plus the square root of 17.596 divided by 0.74, which would give us 11.2, and then we would take 4.1 minus the square root of 17.596 divided by 0.74, and that would give us approximately a negative 0.1. And we know we cannot have a negative when it involves time. So we would add this 11.2 to 1990. So about 2001, hospital spending will increase to 11.7%. And we're done with that problem.